My dear students, today I am going to discuss class 10 physics, the chapter of electricity. In that chapter, there is this very important formula R equal to rho L by A. Now, today I am going to discuss a few concepts involving this formula. Now, first of all, see the meaning of these letters. Now, suppose this is a conductor, say electric wire. Now, an electric wire is cylindrical in nature. So, I am just magnified many times. So, usually it looks like a straight line, but actually since it is cylinder, so it will be like this. Now, this cylinder has a cross-sectional area. So, these two faces are circles. If you cut any place, you will get circular face. Okay. Now, that cross-sectional area is A. So, this A is the cross-sectional area of the wire. This L is the length of the wire. 1 meter, 2 meter, that way. So, L is length of the wire. And this R is resistance of the conductor. So, this particular portion of the wire has resistance R, cross sectional area A, length L, and this implies this represents a very important property of the material of the conductor. Now, suppose this is copper. Now, copper, this rho, it means the resistivity or specific resistance. So, there is a term called resistivity or specific resistance. So, that is represented by this Greek letter rho. Alright. Now, specific resistance or resistivity is a very important inherent property of the material of the conductor, not of the conductor or resistor, but of the material. Suppose this wire is made up of copper. Now, copper has a constant resistivity, which is about, let me tell you. Now, all these resistivity values are given in your textbook. Now, copper resistivity is 1.7 into 10 to the power minus 8 ohm meter. So, ohm meter is the SI unit of resistivity or specific resistance. Now, for copper, suppose this wire is made of copper, it has this resistivity, this value. Then silver has this value 1.6 into 10 to the power minus 8 ohm meter, like that. That way, different materials have different resistivity. This is inherent property of the material. All right. Now, between any two material, resistivity, say between silver and copper, silver resistivity less, copper resistivity little more. So, therefore, silver is better conductor than copper. If resistivity is more, then that material is a worse conductor. If resistivity is less, then that material is better conductor. If you compare this copper and silver, copper has less resistivity, therefore it is a better conductor than copper. All right. So, that is the meaning of this letter rho, which represents resistivity of the conductor. Now, if you look at the formula, you will see the relation. So, this R resistance is directly proportional to L and resistance is inversely proportional to E. So, resistance is directly proportional to L. That means if we increase the length of a conductor, then resistance of the conductor will increase. So, directly proportional, that means if you double the length, then resistance will be doubled. If you make the length 3 times, then resistance will become 3 times. If you make the length half, then resistance will become half. So, directly proportional. Now, this is inversely proportional. So, resistance of the conductor is inversely proportional to cross-sectional area. If you double the cross-sectional area, then resistance will become half. If you make the cross-sectional area half, then resistance will increase to double because it is opposite, inversely proportional. All right. So, this is the relation between RL and RE. Okay. All right. Now, coming to a particular question. Now, suppose this is a question. If length of a wire is doubled, if length of wire is doubled, If length of wire is doubled, how will the resistance change? So that is the question. If length of wire is double, how will the resistance change? Now suppose this is a wire 1 meter. This is a copper wire 1 meter. Now this is another wire copper the 2 meter. So this is a wire of copper 1 meter. This is a wire of copper same material 2 meter. Now see, this is double of this. Now if this wire has resistance R, then this wire will have resistance twice R. Since length is doubled, so resistance will be doubled, because you see this relation. Resistance is directly proportional to L. So if L is doubled, R will be doubled. If L is made 3 times, R will be made 3 times. As I told you before, if L is made half, then R will become half, because directly proportional. So between these two wires, this is 1 meter, this is 2 meter. So wire length is doubled. So what will happen? How will the resistance change? Resistance will also be doubled. The right answer will be the resistance will be doubled. If it is 1 R, it will be 2 R. If it is suppose 10 ohm, this will be 20 ohm. Now this answer we get from this relation, but then numerically you have to prove in exam. All right. Now this is how we can prove it. Now say the first wire. So first wire, suppose let us consider the first wire. First wire, suppose resistance is R, length is L, cross sectional area is A, and then resistivity rho. Suppose in the first wire, this is the first wire and this is the second wire. So second wire is double the length of the first wire. So in the first wire, resistance is R, length is L, this length is L, this length is twice L, all right. So length is L, cross sectional area A, and resistivity of the material, suppose both made of copper, rho. So therefore, using this formula, what is R equal to? R equal to rho L by E. Okay, this is the first wire. Now come to the second wire. For this second wire, what resistance is, suppose resistance is, now first wire, let us call the resistance R1. So this is R1. For a second wire, R2. So R2 length is twice L, then cross sectional area same kind of wire. So therefore cross sectional area will remain same, and rho obviously same, because both are made of, suppose, copper, same material. So therefore what we get? R2 we get rho into twice L, rho into length, isn't it, by area A. Okay, now yes, to find the ratio to compare R1 by R2. So therefore R1 by R2. So if you divide R1 by R2, what you will get? Rho L by A divided by this. So rho into twice L by A will go up, isn't it? Yes. So rho L by, now cancel, A cancel, so rho cancel, then L cancel. So what we get? This is 1. So R2 equal to 2 into R1. So you see, so R2 is 2 into R1. That means this one. Second wire resistance is double the first wire resistance. So when you make the length double, so when you double the length, then what happens to resistance? Resistance also becomes double. This is the answer. Numerically we have, or mathematically we have proved it. Okay. All right. So this was question 1. Now come to another question. Yes. Okay, this is the thing. How will if length of a wire is doubled by if length of a wire length of a certain wire if length of a certain wire is doubled, if length of a wire is doubled, if length of a wire is doubled by stretching it, if length of a wire is doubled by stretching it, by pulling it, or sometimes the question is given by melting and redrawing it. So if length of a certain wire is doubled, how doubled? By stretching it, or by pulling it, or by melting it and redrawing it, reshaping it, then how will the resistance change? So in this problem there is only a single wire. That single wire is what? Melted. It is melted and it is redrawn, reshaped, or it is pulled, it is stretched, so that the length becomes double. Then how will the resistance change? Okay. Yes, now, so before stretching, let us see uh, resistance is R. Resistance, suppose R1. All right. Then length L. Okay. Then cross sectional area A1. Now when you pull it, the wire becomes thinner. A particular wire, when you pull, then the cross sectional area will decrease because the wire will become thinner. All right. So the A1, this is the area, and then resistivity is what? Rho. So therefore, what is the relation using this formula? R1 equal to rho into L by A1. So this is the resistance of the wire before stretching. Okay. Now let us see what happens after stretching. So this is before stretching. Now let us see what happens after stretching. After stretching or after melting it and redrawing it. Okay. So the now length is doubled. So L will be now twice L. This is the second shape. So after stretching or after melting and redrawing, the resistance, let us say R2. Resistance becomes R2, then length doubled. Cross section area A2. Cross section area will change. It will become, the wire has become thinner because of stretching or pulling. And then resistivity, of course, will remain same. Resistivity will remain same, rho. So therefore what you get? Therefore what is R2? R2 will be what? R2 will be rho into twice L, length is twice L, by A2. So R1, R2 different and A1, A2 different. Okay. All right. Now you see what is the relation between A1 and A2. For that purpose, let us see about volume. Now you see, I mean, both the wires have the same mass and therefore same volume. Now when you melted and reshaped it, redrew it, or stretch it, all right, then mass does not change, volume does not change. So what has changed? Only the length has changed. Length has become double. So volume of the first original wire before stretching and the wire after stretching, of course the same wire, therefore volume will remain same. Now in the first case, what was the volume? Volume was L into A. So volume of a cylinder is what? Volume of a cylinder. You see, the wire is a cylinder. So what is the volume? This is length L, and this is cross sectional area A. So A into L. Volume of a cylinder is what? Cross sectional area into length, A into L. Okay. So the original wire had this volume, and after stretching, after redrawing, the volume has become what? Volume has length into length is now twice L. Length is now twice L. Length into area is this is A1, this is A2. So before stretching, the volume was length into cross sectional area A1, and after redrawing or stretching, the volume is what? Twice L, length and then cross sectional area A2. Now these two are same, volume same, therefore these two will be equal. So therefore 2L into A2, that is equal to L into A1. So L cancel, therefore what is A2? A2 equal to A1 by 2, A1 by 2. So this is the new area of the new wire. Now new wire is thinner because you have pulled it. So thinner, therefore obviously its cross section area will decrease. So new cross sectional area has become half of the old. So the new cross sectional area of the new wire is what? A1 by 2, half of the original. Now this value you see we'll use now. Okay, now like before, like the previous sum, so let us divide R1 by R2. Now when you have to compare, find the ratio, compare and all that, try to divide. So R1 by R2. So R1 is what? This one, rho into L by A1 divided by R2, divided by R2. So rho into twice L, rho into twice L by A2. A2 will go up, this one. So this divided by this, A2 will go up, all right. So this becomes what? Rho into L into A2. What is A2? A1 by 2. A1 by 2. Okay, and denominator A1 into rho into twice L. Okay, so L cancel, L cancel, rho cancel, A1 cancel. What is left? 4. What is left? 1 by 4. So R1 by R2, R1 by R2 is what? 1 by 4. 1 by 4. Okay, so this gives R2. So R2 equal to what? R2 equal to 4R1. R2 equal to 4R1. So this is the relation between the new resistance of the new wire and the old resistance of the old wire. Now see the new resistance. Now original wire is this one. Suppose this is 1 meter. Now by pulling, you have made it 2 meter. So now the new wire is thinner. New wire has become thinner. Now thinner wire has more resistance. Thicker wire has less resistance. Thinner wire has more resistance. Now the new wire is thinner than the old. Therefore its resistance is more. 4 times the resistance of the old one. So how will the resistance change? So your answer will be the resistance will increase to 4 times. So the new resistance is 4 times the old resistance. So what will be the answer to this question? How will the resistance change? The resistance will increase to 4 times. The resistance will increase to 4 times. Now why resistance will increase to 4 times? Because you have double the length. Double the length. Double means 2 times. If you increase the length to 2 times, the resistance will increase to 4 times. 4 is 2 square. Now it is like a formula. If you increase the if you increase the length to 3 times, the resistance will increase to 3 square times, that is 9 times. So this 4 is 2 square, 2 square is 4. Now if it is 3, this will be 3 square 9. That means the resistance will increase to 9 times. You followed? Similarly, if it is 4, then it will be 4 square, that means 16 times. If you increase the length to 4 times, if you increase the length to 4 times by stretching, by pulling, then resistance of the wire increase to what? 4 square, 16 times. So therefore it is like a formula. So n square. So remember this formula. If we increase the length to n times by pulling, by stretching, or by melting and redrawing, if we increase the length to n times, then resistance will increase to n square times. So this is like a formula. Okay. So you see the difference between this question number 2 and question number 1. In the previous question, we took two different wires. Two different wires, but here the same wire, only it has been pulled and reshaped, or it has been melted and redrawn. Okay. Okay, now let us see the third question. Now this is a question. The third question is this: how will resistance of a wire change if its diameter is doubled? So how will resistance change if its diameter, or radius, if diameter or radius is doubled, If diameter is double, of course radius will be doubled. If radius is double, diameter will be doubled. Okay. So how will the resistance of a particular wire, this is one wire, of a certain wire change if its diameter or radius is doubled? Okay. Yes. Now let us see this one. All right. Now you see these two wires. This is the first wire. Now I have magnified it so that it looks like a cylinder. So this is the face, this is the face. Okay, suppose this is the length is L. Length is L. Now diameter is double. Now length remains same. Only diameter is double. That means it has become now wider. You see, like this. Length remains same. Length of these two wires, length of this wire same. Diameter is double. So these here these two are different wires. These two are different wires. Length is same. Then resistivity is same. They are made of, suppose, both copper, same material. Now only difference is what? Diameter is double. So suppose this diameter is D. This diameter is D. Then this diameter is twice D. And suppose radius is R. So this radius is twice R. So therefore this wire is thicker. This wire is thicker than this. Now thicker wire will have less resistance. So between two wires, the thinner wire has more resistance, thicker wire has less resistance. So if this resistance is, suppose, R, then this resistance will be definitely less than R. So that is what we have to find mathematically. Okay. All right. So like before, let us see now the first wire. This is the first wire. This is the first wire. This is the second wire. Now for the first wire, let us say resistance is R. Resistance is R1. Resistance is R1. Resistivity rho. Then length is L. And diameter suppose D. Diameter D or radius R. Now in the question, sometimes they will mention diameter and sometimes radius. If radius is mentioned, you take R. If diameter is mentioned, you take D. All right. Now the second wire Yes, resistance is R2. Then rho resistivity same because they are made of same material. Okay, now length is same. Both the wires have same resistance. Only what is the difference? Diameter or radius is difference. So diameter is what? Twice d. And if you think of radius, it will be twice r. Okay. I hope this point is clear. If diameter is double, radius will be double, isn't it? Suppose a wire has diameter 20, then what is its radius? 10. Okay. If a circle has diameter 20, its radius will be 10. And if diameter is doubled, that means new diameter is suppose 40, doubled. And what will be the new radius? 20. Isn't it? So when diameter is doubled, radius is also doubled. Okay. All right. Now, so for the first wire, yes, let us use the formula R1 equal to, what is R1 equal to? R1 equal to rho L, R1 equal to rho into L by A. Okay, now for area we'll use that formula. Area of a circle is what? Pi r square. So area, cross sectional area, this is circle, isn't it? This is a circle, therefore area will be pi r square. So what will be the area? Area will be pi r, this r, pi r square. You follow? So this first wire resistance R1, then rho into L, length is L, and then cross section area is pi r square, so pi r square, radius is r. Then the second wire, for the second wire resistance is R2, isn't it? Then rho is same into L is same by A, area is what? Pi into r square, r is twice, yes, so radius is what? Twice r. The first wire radius r, second wire radius twice r, isn't it? So this becomes what then? Rho into L, then here 4 pi r square, all right. So this is R1. Okay, now this is R2. Now we'll divide. So R1 by R2. So now let us divide R1 by R2. So R1 by R2. So now I'm doing here. Okay. So this one. So now R1 by R2. So therefore R1 by R2 is equal to what? R1 is this one, rho into L by pi r square, divided by this, divided by R2, divided by this. So rho into L by 4 pi r square. This will go up. So 4 pi r square. So R1 divided by R2, this divided by this. So rho L pi r square, divided by this. So rho L by this one will go up. All right. Now by cancelling, what do you get? You see pi r square gone, L gone, rho gone. So what remains? 4. So what remains? 4. So therefore, finally what we get? R1 by R2, 4. Therefore R2 equal to 4R1. So this is the final answer. So what is the final answer? The new resistance is 4 times the old resistance. So the question is, how will the resistance change? So answer will be, the resistance will increase to 4 times. Now why the resistance will increase to 4 times? Resistance will increase to 4 times because 1 minute. R2 equal to R2 equal to 1 minute, R1 by R2, 4 pi r square, and this is 4 pi r square. So R1 by R2. So this 4 pi r square or R, oh yes, sorry, this is equal to 4. So this R1 by R2 equal to what? 4. Therefore, R2 equal to 1 by 4 R1. 1 by 4 R1. Yes, this way. So what will be R2? R1 by 4. R1 by 4. R1 by 4, that means 1 by 4 R1. Yes. Now what will be the answer? How will the resistance change? So your answer will be the resistance will become 1/4. The resistance will be reduced to 1/4. Obviously, now you see, you have increased the radius, you have increased the diameter, so wire has become thinner. Now thinner wire have become thicker. The thicker wire has less resistance, thinner wire has more resistance. So the thinner wire has been made thicker, therefore resistance will decrease. See, resistance has decreased. It has decreased to 1/4 of the original. So what will be the answer? The resistance will decrease to 1/4. The resistance will be reduced to 1/4 of the original resistance. So this is the answer. So I have shown you 3 different types of questions involving this formula. Okay, so these are very common in exam. All right, for today, we'll stop. Thank you.